Good. So after probability, we look into probability distributions, and we'll cover random variable, its mean and variance, binomial theorem, and Poisson distribution in this tutorial. Okay? So why do you think we need to know about probability distributions? Is knowing probability not enough? Why is that? What extra information does distributions give us? Why would that be of interest? Okay. Any other idea? That's not
a wider range to look at,
okay.
which shows you how high probability that area of the range or how low they are on that range.
Okay.
For like keys and like real life examples, you can like see how risky something is possibly like investment.
Right. So building on your point, it's about choices of the things and what are the probabilities and outcomes of those choices. Right? So if you walk in a phone store to buy a phone, you have a choice of buying an iPhone, you have a choice of buying a BlackBerry, a Samsung, an LG, whatever you want. And there's a probability associated with each one of them. So if you walk in a phone store today, you possibly have a 90% chance of buying an iPhone 4. Right? And there's a price for iPhone 4. So a seller who's selling the phone now has an expected value of each transaction. Now knows what's the probability of an iPhone 4 going on the shelf and how much he is going to get in return. Okay? If for iPhone, BlackBerries, LG, and say Samsung, this is 0.9, this is 0.7, 0.05, 0.05. How much is an iPhone 4 for? Any idea? 500? So let's take 450. 450 quids. How much is the BlackBerry for? 400 maybe, approximately, if you're looking at the torch. How much would an LG be, say 200, Samsung say 300, okay? So now if these are your options when you walk in a phone store and you buy one purchase, what is the seller doesn't know what you are going to purchase, okay? What is his expected income? Before you make the purchase, the seller does not know what you are going to purchase. This can be one of you, this can be all of us. So a seller needs to know in a month what can be his expected income so that he can plan for the future, so that accordingly he can take stocks of it. Right? So the expected income of a seller is nothing but the probabilities multiplied by the prices and the sum of that. Okay? That gives us the mean of the distribution, which is nothing but sum x, which is this, and the probability of that event happening kx. Okay? That gives you the mean of a distribution, the mean value of a distribution. Variance, as we all know what variance is, and what is variance? Not the formula, but the concept. How spread the data is. How different the data is from the mean. How apart the data is from the mean. So for each data, we take it from the mean, we square it. Why do we square it? Negative value. Brilliant. Multiply it with the probability. That gives you the variance of a distribution. Okay? These are all mean and variance of a random variable. What is a random variable? What would you call a random variable? Maybe somebody from this side of the discussion table. What is a random variable? Give me any random answer, I don't care. This side of the discussion table? What is a random variable? third gentleman. What is a random variable? What is your idea of a random variable? Go on. Okay. Yes, gentleman in blue sweater.
Sorry. What I read well.
Yeah.
I think read well is when it has the same likelihood to occur than any other variable. So it's random.
Okay, that's a random
That's the
experiment,
right.
right? A random variable is an outcome of a random experiment. Although it's called a random variable, very strangely, it's neither random nor variable. Okay? So random variable is a variable which takes on a value, a numerical value, which can be discrete or continuous, depending on a particular outcome. Okay? So a discrete random variable would possibly be the number of pints of beer sold in Trial College Bar every day of the weekdays. Okay? That's discrete. Whereas a continuous random variable would be the time the student walks in this tutorial. So it can be 12, it can be 12:30, it can be 12:21, it can be 12:50. Right? So those are random variables. To understand how random variable works and how this affects our decision making, let's look at the problem. Is it 4.49? Many of you from here would graduate on and become an investment banker, a hedge fund analyst. So question 4.49 possibly, if I'm not wrong, gives you an opportunity to understand how you base your decision, how you sell investment portfolios to your investors. Is a 4.49? No, that's 4.29, I'm sorry. 4.29? What does 4.29 say?
Three strategies.
There are three strategies.
For the first one, you've got a profit of 10,000 with a treasury of 0.15.
Okay, so for each strategy, we have an outcome and a probability of that outcome. The outcome can be a gain or a loss. Okay? An investor comes to you with a kitty of 1,000 quid, isn't it? And you have three investment portfolios to sell him. Which one would you recommend? Or taken from another angle, if I'm the seller of these investments, which one are you buying? So for strategy one, the outcomes are a profit of 10,000 quid, for which the probability is 1.15, or a loss of 1,000 quid, for which the probability should be 0.85. For strategy two, 1,000 profit, 0.5, 500 profit, right? Good. And strategy three does not have a probability, it has a certainty.